Okay, what's an operator wish list? I hope I got this right, because there are a couple of operators here. Flexibility of transport, format, and interfaces as they evolve. Flexibility of any capacity as the requirements are evolving rapidly. Flexibility of networking protocols. ISIS, OSPF, now we have segment routing with MPLS. They're changing, they evolve. Flexibility of provisioning an operations layer. Yes, I like SDN, but it's going to cost me more money. I don't need that. I want NFV, and so on. Independence of transport, of protocol layers, of provisioning functions, and of timing. So that when you change something in the network, you don't have to change all of these as well. There's nothing more disturbing than having to change out your timing network simply because you want to add some radio functions. So these are drivers for SDN, of course. And timing services, wish list. Deterministic, well, that makes sense. Reliable. Timing is going to be the core of the 5G network. Synchronization is the lifeblood, it's the heartbeat of your 5G network. It's a TDD network. Traceable back to a PRC. That's even regulatory in some environments. Resilient. In other words, good handover, good switchover. Future-proof. Well, that would be great. If I could put in a timing network that would last just like the old SSUs do. I hate SSUs. You know, I'm selling these things, and carriers don't change them. They put them in 25 years ago. Telstra, I hate Telstra. They've still got TSGs. They were built in 04 or something, right? You don't migrate a timing network like you migrate an Ethernet network. As you roll out faster core, faster edge, faster access. I have a client in Asia, he's planned his 10 gig access network. Now he's got his 40 gig access network planned, and he's got plans to migrate that eventually to 100 gig at the edge, and each time it means swapping out the routers, and each time he does that, he's going to have to change the clocking architecture. That doesn't make sense to me. Does something that doesn't have to be engineered and re-engineered with changes in the transport protocols, provisioning, or network infrastructure. In other words, let's dissociate something that's as critical as your heart from, you know, if I have a finger problem, right? And this is why SyncE was predicated on SDH, because SDH was known to be very stable, physical layer. We could migrate, you know, we could leave SSUs in place and just have the same frequency running 4.6 ppm inside the routers as we do inside the ADMs and migrate simply. So how do we do this for time and phase? Because time and phase until now has been a PTP is packet, and packet is Ethernet, right? And that's got to put Ethernet switches. That means routers, and that means when you change them, you change the clock. You want cost reduction. You want predictability. These are all things that carriers would prefer to have.